Hello there everyone and welcome back to Learner Labs. In this video we'll be looking at volume and surface area. In the previous video we looked at area and perimeter. I'll leave the link to those videos down in the description. Don't forget to check it out. So let's get into the video now. Volume of a cube. You see, a cube is made up of squares. Squares have equal sides. So a cube also has equal sides. So the formula is side times side times side. And the formula length times width times height also works with a cube. So here, the cube has a length of 5, a height of 5, and a width of 5. You can also say it has a side of 5 centimeters. So if you substitute it in the formula, you get 5 times 5 times 5, which is 125 centimeters cubed. The volume of this cube is 125 centimeters cubed. Volume for cuboids and rectangular prisms. So the formula side times side times side doesn't work on a cuboid as it has different lengths. So the formula is length times width times height. So I'll show an example. So this cuboid over here has a length of 7 centimeters, a height of 5 centimeters, and a width of 3 centimeters. You substitute it in the formula, you get 7 times 3 times 5, which is 105 centimeters cubed. So the volume is 105 centimeters cubed. So volume of a cylinder. So you need to know the volume of the cylinder in order to find the volume of a cone. So the volume is height times pi r squared. So this is because when you move on from 2 dimension to 3 dimension, you multiply the values by 3. So you do the same. Pi r squared is the area formula for a circle. So you multiply it by height, which is the 3rd dimension, you get a volume of a cylinder. So yeah, I'll show you an example, which is here, r is 5 centimeters, height is 6 centimeters. So if you substitute it, it's 6 times 5 squared, which is the radius, times 3.14, which is pi, which is 471 centimeters cubed. So the volume of the cylinder is 471 centimeters cubed. Volume of a cone. As I told you guys before, 3 pyramids arranged in a specific order can give you a cube. 3 cones arranged in a specific order can give you a cylinder. So keep that in mind. So the formula is height by 3 times pi r squared, as height times pi r squared is the volume of a cylinder. So I'll show you an example. So here the height is 6 centimeters, the radius is 5 centimeters. So if you substitute it, and the formula is 6 by 3 times 3.14 times pi squared, which you get 157 centimeters cubed. So the volume is 157 centimeters cubed. Volume of a sphere. This is the most tricky in what I'm telling you today. So the formula is 4 by 3 pi r cubed. Notice that it's pi r cubed, not pi r squared. So I'll show you an example. In this example, the radius here is 5 centimeters. So the volume is, you substitute it, which is 4 by 3 times pi, which is 3.14, times 5 cubed. So you get 523.6 centimeters cubed. So the volume is 523.6 centimeters. We're now done with volume. Let's move on to surface area. Surface area of a solid object is the measure of the total area of an object's net. I'll show you what an object's net is. Nets or geometrical nets. A net is a flattened out 3-dimensional shape or a solid. You get a net when you cut an object face by face, and when you fold it back, you still should get the same face. That's what a net means. If you don't get the same shape, it's not the object's net. So an example for a cube's geometric nets are, here is a cube, and if you cut a cube face by face, you get a net, which is this. Here is the net for a few shapes. From now on, I'm going to be showing the table strategy for specific shapes on how to find the surface area. Table strategy is the way of organizing all the faces and then calculating their area and adding all the area together to get the surface area. For some shapes, like cones and spheres, the table strategy doesn't work because of their circle-like faces. They're hard. So now, surface area of a cube. So a cube has 6 identical faces. So the surface area of a cube is 6 times the area of one face. So this is because cubes are made up of squares, and squares have equal sides. So cubes also have equal sides. So here there is a 6 cross 6 square, and there are 6 identical of them in this net, which is 1, 2, 3, 4, and 5, and 6. So area of one face or square is 6 cross 6, which is 36 centimeters squared. Surface area of the cube is 6 times area of one square or one face, which equals 6 times 36 centimeters squared, which is 216 centimeters squared. Surface area of a cuboid or rectangular prism. This is the table strategy, so yeah. I'm also including the formula right here. So the formula is 2 times L times W plus W times height, and height times length, or the sum of all the 6 faces, this area, which is A's area plus B's area plus C's, D's, E's, and F's. So, table strategy. Here, B and D are identical, C and F are identical, A and E are identical. So, this here represents B and D, which is right here. So, their measurements are 5 cross 6, and there are 2 of them. So, A and E has a measurement of 7 and 5, and there are 2 of them. F and C have 2 of them and has a measurement of 7 cross 6 centimeters. So here I calculated the area, and then I calculated the area of 2 identical faces by multiplying the area of one face. Then I added all the area to get 216 centimeters squared. Surface area for a triangular prism. So here is a net diagram of a triangular prism. So the triangle over here in the left-hand side is the triangles D and E. They both are having the same measures, so they are identical. So yeah, this rectangle is A, this rectangle is C, and this rectangle is B. So here I calculated the area for one face, and since these 3 over here had only one of them, I just multiplied by 1. But for these triangles, there are 2 of them, so I multiplied it by 2 to get 20. At last, I added them all up, and I got 104 centimeters squared. Surface area of a cylinder. So here is a formula, which is 2 pi times r times h plus r. That's the formula, but here I'm going to be telling the table strategy. So I've done 2 models representing the faces. So these are the top 2 circles, one on top and one on bottom. And this is the rectangle that connects them. There is no length, but you can find the length by finding the circumference of the circle. So area of one base is pi r squared, which is pi 3 squared, which is 3.14 times 9, which is 28.27. So there are 2 bases, one on top and one on the bottom, which is 2 times 28.27, which is 56.54. So here, first you need to find the area for this rectangle. The formula is length times width. As you don't know what the length is, you use the circumference strategy, or how to find the perimeter of a circle here, which is 2 pi r times 5. We just substituted to pi r instead of the L. And first we do this part, which is 6.28 times 3 times 5 centimeters, which is 94.2 centimeters. And the last step is you add them all. When I added them all, I got 150.74 centimeters squared. Surface area for a sphere. This does not work on the table strategy because of its curved faces. So the formula is 4 pi r squared. So I'll substitute it to show you an example. So here the radius is 5. So if you substitute it, it's 4 times 3.14 or 22 by 7, which is pi, times pi squared, which you get 314 centimeters squared. Surface area of a cone. This also does not work on the table strategy. So, formula. The formula is pi times r plus L, in which you do r plus L first. Here, the L stands for the slant height, not length. It's the hypotenuse of r and h, which is also known as L squared equals h squared plus r squared. So I'll show you an example, as this is a tricky one. So here the height is 4 centimeters, the radius is 3 centimeters, and the slant height is 5 centimeters. So the surface area is 3.14 times 3 times 3 plus 5, which is 75.36 centimeters squared. Points to remember. Volume is the space occupied by a three-dimensional object. Capacity is the amount an object can hold inside it. Volume and capacity use the same formulas, and here are the formulas for each shape. Surface area is calculated based on the area of the 3D object's net, using the table strategy or the formulas. So here are formulas to remember. Don't forget to share this video, like this video, and subscribe to my channel. I'll see you on my next video. Until then, bye-bye.